Hi everyone, in today's video I would like to briefly explain the recent hype regarding DeepSeek, explain a bit the context where it's coming from, and also what you might expect in the future. Let's start off by just going over how we basically got to today, how we got to this release of DeepSeek, which basically made it to mainstream. And then I'll also talk a bit about the current trends that we see in the industry, and then finally why open source might be a better idea if we want to make more progress on artificial intelligence in general. Let's start by how we got to today. So basically, to give some context, in 2017, Google released a paper called "Attention is All You Need," where they introduced a new neural network architecture called the transformer. This transformer neural network architecture was initially introduced to perform machine translation, so translating, for example, English to French, and it did that much better than all the other AI models that came before that. And so Google open sourced this work, so they released the code on how to implement a transformer yourself. They released a whole research paper describing everything. And soon after the transformer came out, a lot of models started to pop up that were all based on that original transformer architecture. And one very important one is the BERT model, also developed at Google and also open sourced, because this really was like a revolution in the world of natural language processing, or NLP. Because suddenly you could have like an AI model that could easily get 90% accuracy to perform things like text classification. For example, if you wanted to classify your emails into spam versus not spam, BERT was just a lot better at that than previous models. And also for things like extractive question answering, where the model must be able to answer a certain question by extracting the relevant context from a piece of text. BERT was just much better at that than previous models. The T in BERT stands for transformer, so it's based on the original transformer model from Google. As BERT was openly available, it was open sourced by Google. This actually gave birth to the Hugging Face Transformers library, which is an open source package that includes a lot of openly available AI models that are all based on the transformer. Right now there's the Hugging Face Transformers library, which provides easy access to a lot of transformer-based models, including BERT. And so this is in 2018. And so 1 year later, in 2019, OpenAI, they released a model called GPT-2. So before that, they already had GPT-1, but it was GPT-2 which really made it to mainstream, because this was like the very first time that an AI model could generate human-like text in a way that was very hard to distinguish whether it was written by a human or whether it was written by a computer. So they give, for example, this system prompt regarding scientists that discovered a herd of unicorns living in a remote unexplored valley, and then if you give that prompt to GPT-2, it was able to complete that prompt in a way that seems very human-like. So this was the very first time that a computer could generate text in such a good way. OpenAI, initially they also created some hype around this, because initially they didn't actually want to open source GPT-2 because they said it was too dangerous to release it. They were afraid that there were too many potential misuses of this model, like for example generating fake news, automatically completing homeworks, things like that. But as it turned out, this GPT-2 model was actually not that powerful as people thought it would be, and so eventually it was open sourced, and it was also integrated into the open source Hugging Face Transformers package. Now, to give some more context regarding OpenAI. So OpenAI, if you check their Wikipedia page, they're actually a company that were founded around 2015, 2016. And so their initial goal was to do artificial intelligence in an open way. So by open, we mean that you release research papers regarding the things you find out. You release the code for how you implement these AI models, and you also release what is called the weights, which is like a file containing the actual intelligence or knowledge of these AI models. This company was founded by several people, including Elon Musk, and initially, and that's also where the name OpenAI comes from, was to basically do AI research in a fully open and transparent way to benefit all of humanity. That's what their mission was. And so initially they stuck to that mission. So with models like GPT-1 and GPT-2, these models were openly available and research papers were also released. So in 2019, this was still the case when GPT-2 came out, although it took some time before eventually they released everything. But then in 2020, their business model changed, because at that moment, they basically scaled up their smaller GPT-2 model to GPT-3, which is actually a very similar idea as GPT-2, except that it's scaled up. So in terms of size of the model, so the model is much bigger, has much more what is called trainable parameters. It's trained on much more data, and there's a lot more compute involved. So you need GPU hardware typically to train these neural networks. So they scaled up across all these three dimensions. The benefit of GPT-3 size models was that they could perform what is called in-context learning, or also called few-shot prompting. So basically it means that, as shown here in the left side of the figure, you could give it a few examples. Like, for example, if you wanted to do machine translation with this GPT-3 model, you would just give it, for example, 3 example pairs of English to French. And then if you give it like a 4th English word or sentence, it could, like, out of the box translate that into your desired language. So it could perform new natural language tasks out of the box with, like, either no examples, which is called zero-shot learning. So there we would, like, directly ask GPT-3, translate this from English to French, then give it the word cheese, and hope that it will directly generate an answer. But you can also add a few examples in your prompt, which is called few-shot learning. So the model can basically learn a new task on the spot. So we're actually not, like, training anything. We're not updating the weights of the model, which is what people used to do before that. So that's shown on the right side of the figure. This is called traditional fine-tuning, where you would, like, take the weights of this GPT-3 model, and then based on your labeled data set that you have, you would, like, update the weights. So using gradient updates to make sure that the model is able to perform a certain task. Now, at that moment, OpenAI saw the business value of these models, saw the incredible value of being able to perform a certain task without any traditional fine-tuning. And so that's the moment where they started to become more closed source. So GPT-3 itself was not available anymore in an open way. So they still released a quite detailed research paper for this, but the model itself was not openly available. So you could only access it through what is called an API, which means you can only access it in a programmatic way by sending your text prompts to OpenAI. They will process it for you, and then they send a response back. That's a bit the start of OpenAI becoming more closed. And then 2 years later, in 2020, ChatGPT was born. So ChatGPT is also you could say a new version, an evolved version of GPT-3. But it was, like, the very first time that these AI models became very useful for people as, like, general AI assistants, where you could explain it very complex terms in simple terms, or you could ask it to help you with your homework, or you could help you with drafting content and so on. And so that's really the moment where these GPT kind of models became mainstream. Lots of people, including, for example, your parents, might know about ChatGPT, and they also released another API-based model. So again, it was closed source. You could only access it in a programmatic way, which is the GPT 3.5 model. which at the time was relatively cheap to basically send your text prompts to it, and then you get priced per 1 million tokens, which are like kind of words that you send to the API. And so the way this ChatGPT model was created basically involved 4 stages. So I took this slide from a presentation from Andrej Karpati, where he discussed how to create such a GPT assistant or ChatGPT kind of model. So it involved first a pre-training stage where you ask the model to predict the next word or token on billions or even trillions of words on the internet. And then this is followed by a supervised fine-tuning stage, so where you could basically take your pre-trained model, which is typically also called a base model, because it's not that useful yet because it has been simply pre-trained on predicting next words on the internet, on a lot of text from the internet. But you could take such a base model and turn it into a useful assistant by basically training on a lot of prompts and corresponding completions. So an example here could be a prompt, give me a recipe to make pancakes, and then the corresponding completion would be the actual recipe for making pancakes. So this data is then typically human labeled, so this is why it's called supervised fine-tuning, because you need humans to supervise the model to basically create these prompt and completion pairs and then train the model on that. So then you have your SFT model or supervised fine-tuned model, and then the final stage, which in this slide is shown in 2 separate stages, you could view as one, is called RLHF or reinforcement learning from human feedback, where again you would involve humans to basically compare 2 different completions of your GPT assistant model and then ask them which of the 2 they prefer. And then based on these human preferences, you would basically train the model with reinforcement learning, which is a type of machine learning, to basically ensure that the model makes it more likely to generate responses that humans prefer over those that they don't prefer. But so again, it was generally known how this whole GPT assistant training pipeline worked, but nobody was really capable of reproducing anything with the same performance. And especially here, like a lot of details regarding their training data were just kept behind closed doors. And then in 2023, so a year later, well, actually only a couple of months later after ChatGPT and GPT 3.5, OpenAI came up with GPT-4, which is like a scaled up version. Again, trained on more data, scaled up in terms of model size, trained on more compute. And at that moment, GPT-4 was really like the best available AI model. But it was like there was a big gap between what was available in terms of closed source API-based models versus the ones that were available in an open way where people could just download these models onto their own devices. So at that time, Meta was working on their Llama series. So Llama are the large language models developed by Meta, and they are available in an open way, so you can actually find these models on Hugging Face and download them and train them yourself. But the performance gap was quite large. As you can see on this plot, for example, here what we plot is like the 5-shot accuracy on the MMLU dataset. So to provide some context, if you go to Hugging Face and you go to the MMLU dataset, which you can check out easily, it's basically a dataset containing a lot of exam questions regarding all kinds of domains across mathematics, biology, astronomy, and so on. And so the models basically have like a multiple choice exam. That's with how these models are benchmarked in this MMLU dataset. And so as you can see, like if you give these models 5 chances, because it's called 5-shot accuracy, it's actually giving 5 examples to the model and then ask it to complete a second one. Then you could see that GPT-4 was able to get an accuracy higher than 0.85 versus the Llama's 75 billion model, which had a performance lower than 0.65. So there was quite a big gap here. And in 2024, this only continued with closed source companies like Anthropic, which is an OpenAI competitor, releasing Claude 3.5, Sonnet 3.5, which is a model that was just better at coding than any other large language model out there. They also released something called Artifacts on their website, which allows you to like quickly see the code that these models develop and then also render it. So for example, if the model generates some JavaScript or HTML code, it would like automatically showcase the final design of the website, which is very nice if you want to quickly iterate on it. But again, a closed source model, because Anthropic, which is also a US-based company, was created by some of the people that were the first authors of GPT-3. And so, also here, there was not any openly available model that was on par in terms of performance with it. Another big trend I would say in 2024 is that, we saw some very interesting AI products, like for example, Cursor AI, which is basically a fork of VS Code. So VS Code, or Visual Studio Code, is a very popular software tool for programmers, which they use to code basically. And so Cursor basically created a adaptation of that, where they integrate the Claude Sonnet 3.5 model into it, which allows you to basically code much faster. Cursor is a very nice example, I think, of how to integrate such a large language model into the daily workflow of a programmer, and basically, makes your improvements of your productivity go up by at least a factor of 10. So this was something that was very, very interesting to see in 2024. Of course, there were already some players out there that aimed to like close the gap between open and closed source. So as I said earlier, Meta was actually the first one with their Llama series. So after the first Llama model, currently we're actually at the Llama 3.3 series. So it's already the third iteration of Llama, and we expect to see Llama 4 being released in 2025 for sure. There's also Mistral, which is a European, Paris-based large language model company, aiming to compete with OpenAI and Anthropic, but they also commit to open source models on Hugging Face to basically ensure that knowledge gets shared. But again, here open source needs to be taken with a grain of salt, because they typically then only make the models available but don't give a lot of details regarding their training data. It's the same story actually for Llama. So the models themselves are available on Hugging Face, but it's a bit of a mystery, like how they trained them exactly. Like the code for that is not openly available, and the data sets themselves neither. So that's definitely still a gap with closed source. And then the third big player, I would say, besides Meta and Mistral, is the Alibaba Qwen team. So Qwen is like the AI lab of Alibaba, a Chinese company, and they also produce some really, really good openly available models on Hugging Face. A very recent release, for example, is the Qwen 2.5 series. They also just released a vision language variant of that, which is easily the best openly available vision language model. So they are doing some very, very nice work. So it was nice to see like this gap become closer between openly available models and closed source models, but still there was quite a big gap, because especially with OpenAI then releasing their successors to the GPT-4 and GPT-4o series. GPT-4o is a model that came after GPT-4. Because around November of 2024, they released O1, which is basically also a GPT-based model, but it is trained to perform sophisticated reasoning. So with the earlier models like GPT 3.5 and GPT 4, for example, or any openly available model like Llama, these models would like directly spit out an answer for your given text prompt. So if you ask it, for example, hello, how are you? Then it would like directly generate an answer for that. But if you would ask it also very sophisticated mathematical problems, for example, or coding challenges, it would also directly spit out an answer, which is not something humans, for example, also would do. Like they would first probably think a bit about how to solve or how to tackle a difficult problem before spitting out an answer. So that was kind of a limitation with the GPT-4 kind of models, and so that's something that OpenAI is tackling with models like O1 and then soon O3, which is their next version. They're going to skip O2 because of some copyright issues. But yeah, this is also shown here on the plot. We call this test time compute scaling. So basically, yeah, a lot of the compute to create these models is spent on pre-training them, so on predicting the next words on a giant amount of text from the internet. So this is shown here on the left, the training time compute. And so as you scale that up, the more compute you throw at pre-training, and also actually on the post-training stage, which is the stage after pre-training, which is typically the reinforcement learning stage, you can see that the more you spend your compute on that, the better the performance gets. This is here shown for the accuracy on the AIM benchmark, which is a mathematical reasoning benchmark. But so right now we're also spending more compute, well, at least these models are spending more compute at test time, so at inference time, at the moment that these models need to solve a certain new problem. Since you can see here as well that the more you scale that compute up, so the more time you basically give these models to think before generating an answer, the better it gets. So an example of this is shown here. So let's say you give it this fairly easy problem for a human using the numbers 19, 36, 55, 7, create an equation that equals 65. So with these newer models like O1, you can see that they will first generate and so spend a lot of compute on thinking, on reasoning basically, to then finally come up with an answer. So these models are also typically a bit slower because you first need to let them spend some time to perform what is called chain of thought reasoning. And so it's interesting here also to see that these models are then able to backtrack and fix themselves, like try other approaches before coming up with a certain answer. And so yeah, these models are performing really well on sophisticated mathematical reasoning and coding benchmarks. And again, there was like a huge gap between these models and what was available in the open, like for example on Hugging Face. But that changed, and this is where I come to DeepSeek, this Chinese company, because what they did right now in January is they released a model called DeepSeek R1 in an open, fully open way. It has 685 billion parameters, so it's a huge model. You cannot actually just run this on your own laptop, but you're able to do this if you have, for example, a rack of GPU servers available. And so the performance here, they claim at least, is on par with OpenAI O1. But the difference is that it's fully open source, so it's fully openly available. Again, I'll add some disclaimers because it's not that they also give the details regarding the training data or the code that they used for training or creating DeepSeek R1, but at least the model is on Hugging Face, the weights are available. There's also a technical report describing how they created it, and it's MIT licensed, which means that you can use it for commercial purposes. And so, yeah, it's interesting to see here. So with this DeepSeek R1 model, they are basically on par with the best closed source models, including Claude 3.5 Sonnet, released in October, and also the OpenAI O1 model, which is literally the best model currently available for the closed source companies. But so with the big difference that it's freely available on Hugging Face, it's currently, of course, the top trending model. And interesting is also that they did not just open sourced DeepSeek R1, which is the big, powerful reasoning model, but they also released 6 what is called distilled versions. So distillations are basically smaller models that are trained to mimic the reasoning of the larger model. So this is like a student-teacher setup where you use the larger model as your teacher, and then you take a smaller model, like for example a Llama 70 billion parameter model to then basically learn and mimic that teacher. So this is really interesting and useful for companies because this means that you now have very powerful AI models that you can run at home, for example, on your laptop, because models like a Qwen 32 billion parameter distilled version of R1 can definitely be run at home. And they even go as low as creating a distilled version with 1.5 billion parameters. And so, as I said earlier, there is also some technical reports. So both for DeepSeek V3, which is like the model that came before DeepSeek R1, as well as for DeepSeek R1 itself, they created papers where they describe how they created them. So yeah, there are several tricks involved regarding how they made the training go very efficiently. I'm not gonna go into like the details of how they did that. For that, I would recommend to check out the Hugging Face Journal Club because they created like a YouTube video where they go into detail regarding the technical details of DeepSeek R1. So if you're interested to learn more, feel free to check that out. But the main point I want to make here is that they basically claim that the cost for creating DeepSeek V3, like the base model, so the model that is trained to predict the next word on a giant amount of text, was estimated to be around $5.5 million, which is a huge difference versus the GPT-4 model, for example, by OpenAI, where it was estimated that it was costing around $100 million. And so, yeah, this is the result of a lot of optimal engineering tricks to make sure that these models get trained in the most efficient way on several clusters of GPUs. But this is actually also what made it much cheaper. So this is interesting from Artificial Analysis, which is a very good website if you want to compare various API providers. So where OpenAI is charging $60 per 1 million tokens to use their O1 series, you can see that DeepSeek, which also provides an API for it, so you can also just use it in the same way as you would use the OpenAI models by sending your data to their servers. Then they charge $2 for that, which is of course a huge difference. And this is actually, I think, one of the reasons why we saw a drop in the stock market price for companies like Nvidia. Because I think investors, were a bit surprised by seeing that a Chinese company is able to train an AI model that is on par, basically, in terms of performance with the best models created in the US, despite using much fewer resources. But I will explain in a bit that actually the reverse will happen, and we actually might need more compute, not less. So this is also, I think, a very good disclaimer by Jan LeCun, who is the head of AI at Meta, because some people are comparing this as being a story between China and the US, where Chinese AI companies are outperforming the American ones. But that's actually not how you should look at it. It's rather a story of open versus closed source or proprietary models, because as Jan LeCun is saying, open source is really good because it allows people to basically build on top of each other, share their research. For example, DeepSeek themselves, the DeepSeek R1 model would never have happened without tools like PyTorch, which is the open source software created by Meta to train neural networks. It would also have never happened without models like Llama, because at the time Meta open sourced their Llama series, which allowed people to build on top of it. And it's the same for the transformer itself. Like if Google would have never open sourced the transformer, then even the OpenAI models would have never happened. So it's more of a story about openly available models surpassing the proprietary ones. and allowing people to build on top of each other. So yeah, I think a nice way to summarize this situation with DeepSeek is what is called Jevons Paradox. So basically, with DeepSeek, they basically showed that it's possible to train an O1 level performance model with much fewer resources. Like with an estimated cost of around $6 million, you're able to train a very strong base model, which you can then perform reinforcement learning on top of it to create an R1 model. And so some people might then think that, okay, we might need fewer resources because we're now able to serve these models in a more efficient way. We can train them with fewer resources. But the paradox here is that this will actually ensure that more people will get access to these kind of powerful AI models. More people are able to train and serve them, which means that eventually the demand for these resources, like for example the GPU compute provided by NVIDIA, will only go up rather than down. So I think this is a nice way to summarize. And I also saw that the NVIDIA stock market price already picked up again. I guess it's because people start to realize that rather than AI demand going down, it will actually only go up. And so the DeepSeek R1 model, even though it's fully available, like the weights are available on Hugging Face for you to download for free, there's still a lot of secrets to be unraveled, because their whole data training pipeline was not open sourced. They were quite limited in terms of information in their technical reports. So Hugging Face is working on like a fully open reproduction of that with their Open R1 project on GitHub. This again will allow more people to investigate how we can train these models to perform very sophisticated reasoning, and will allow us to make more progress on them. So that's a bit how we got to today, and why DeepSeek made it to the mainstream media. Let's now talk about some current trends. So one is actually one that I already touched upon. So test time compute. So test time compute is basically making sure that these models can spend more time at inference time to compute, to perform reasoning and a thinking process. The DeepSeek R1 model, for example, shared this as well in their technical report. So the technique here is called reinforcement learning from verifiable feedback. So it basically means that you have some ways to verify whether the output of a certain AI model is correct or not. So this could be either by using another AI model to say whether the response from the AI model was correct or not, but it could also be in a rule-based manner. So if you just, for example, have a compiler that can check whether the code that the AI model wrote can compile successfully, then that can be seen as like some successful feedback or reward that can be given to the model, which allows it to learn from that reward and then updates its weights. And that's a bit how models like O1 and DeepSeek R1 work. Simply from learning from feedback that can be verified, these models learn to reason. And so then we really make these LLMs move from just being very useful AI assistants towards machines that can also perform very sophisticated reasoning problems. So we expect to see more of that in the future, also in the open source world. And you will also see in the technical report, for example, of DeepSeek R1, that the longer they train these models using reinforcement learning, the longer the length of their responses. So the models basically autonomously learn to generate more tokens, to generate more words, basically perform longer reasoning during training. So as your training steps go up on the horizontal axis, the length of the responses generated by the model also go up. And so this can actually go into the millions of tokens, as we already see with models like O3. Another big trend, I would say, besides spending more compute at inference time, at the test time, is agents or computer use. So we see more and more of these models pop up that basically use LLM technology to control a computer, to use your computer to perform a certain task autonomously. So, for example, the video that I took here is from ByteDance, which is the company behind TikTok. So they open sourced a model on Hugging Face called UI TARS, which, if you just give it a certain task like finding round trip flights from Seattle to New York City, then if you just hit enter, what is going to happen basically is a loop where we feed a screenshot of the browser or the computer window to a multimodal large language model, and then it's going to decide like what is the next action that I need to take. Like, do I need to click on some button? Do I need to enter some data? And then the actual action is performed, like clicking on the button. And then the same process again happens. The LLM observes the next action to take. The action is performed on the screen, and so on. So iteratively, the model basically, uses a computer to perform a certain task. So this is actually very similar to the RPA, or robotic process automation technology, that we have seen for many years with software tools like UiPath, except that it's now fully powered by LLM technology. So you might guess that this might work better than what we used to have. Of course, these things are still very early and quite brittle at the moment, but we already see some releases, like, for example, OpenAI releasing their operator system, which is basically computer use with OpenAI models. And this is then combined with these reasoning models to basically make them become better at performing these tasks autonomously. Then a third trend, I would say, is voice use cases. So we also see a lot of speech-to-speech models popping up. So these are models that just directly take in some speech and also produce speech as an output. For example, there's on the closed source side is the OpenAI real-time API, quite popular to start building voice agents. But also on the open source side, you will find various of these kind of omni models, as they call them, on Hugging Face. So by omni, we mean that the model is basically trained on various modalities at the same time, and is then capable of, for example, perceiving not only images but also audio, and produce audio as an output. And this will allow people to basically chat or talk with an AI directly, for example, through a phone. So this might be useful for use cases at call centers, also for HR, so for recruitment basically. Or think about having an AI that automatically ensures that reservations are taken up for a restaurant. So this is definitely another big use case, and that we also see at ML6. And then the final big trend, I would say, the final trend that also was really visible in 2024 is that these AI models, the intelligence that they provide, becomes too cheap to meter. So there was like a huge competition going on between all these kind of API providers that all provide access to an LLM in a programmatic way. And we see the prices only go down and down. And I think a striking example of that is Google with their Gemini 1.5 Flash API, which they provide a free tier for that of 1 million tokens, which are free per minute. So you can actually use their Gemini Flash model entirely for free for 1 million tokens per minute. So that's quite insane, of course. Again, there are some disclaimers here. They do provide these free APIs, but they also do use the data for improving their models. So that's definitely to be taken into account. But it's definitely very useful if you want to already start experimenting with the value of these models, see what they are capable of. And we saw it also now with DeepSeek, ensuring that the price of such a powerful reasoning model goes down from $60 per 1 million tokens to only $2. And there are actually, as the DeepSeek R1 model is openly available, there are already several other API providers out there that also do provide the DeepSeek model with their API. This is another example of intelligence becoming very cheap. This is created with the Transformers JS library, which is a JavaScript version of the Transformers library. And this here is running the DeepSeek R1 distilled version directly in the browser. So there's actually no server going on here. This is directly being run in the browser, performing some sophisticated mathematical problem. So this is just another example to showcase like how we will have very, very smart AI models that can basically run on a toaster. That's basically the trend we're going to see. A final example here is the small VLM model series released by Hugging Face. So these are VLMs, so vision language models, that are very, very small. So you can actually run them at the edge. You can run them because they only require less than a gigabyte of RAM memory. So this will be very useful if you want to do things like optical character recognition, OCR, or you have certain extraction use cases that you want to do, let's say on the receipts. This becomes very, very cheap and also very fast to do. Another very popular example here is Moon Dream, which you can also find on Hugging Face. Okay, so those are like the current trends, and then finally let's just briefly talk about why open source, why is it better than closed source, and why it might win in the future. Well, I think the main benefit of open source is just one, that it avoids that we would have just a few companies, like for example OpenAI or Anthropic, having access to these powerful AI models and let them basically control them. So that's something we want to avoid. We basically want decentralization, where just everyone in the world has access to these powerful AI models, which also creates a safer environment for everyone, because everyone can then start hacking around with them, playing around with them, and see the holes in them. Another example is that, well, and that's actually I think the main reason why open source is just preferred over closed source, is that people can build on top of each other. So research is being shared, so people can make progress. As I said earlier, like if Google would have never open sourced the transformer model with their attention is all you need paper, then BERT wouldn't have existed, GPT wouldn't have existed, and right now we wouldn't have models like DeepSeek R1, which is all building on top of prior research, building on top of prior open source work. So if you want to foster innovation, because there's still so much work to be done to have powerful AI models, artificial general intelligence is definitely not here yet, as you will see if you play around with one of these computer use agents, for example. There's still a lot of progress to be made, also for example in robotics, which is why open source is here to stay. This is also quite interesting. It's an interview with the CEO of DeepSeek. So there's like a rare interview that you can find where they discuss a bit the pros of doing open source, why they're doing it. Of course, DeepSeek themselves, their CEO, their main venture is like a quantitative hedge fund. And it was like rumored that DeepSeek is like their side project. But I think that also needs to be taken with a grain of salt, because they have at least 100 different engineers from some of the top universities in China, having some of the smartest people on the planet. So I'm pretty sure that they also have some very powerful resources to train these models on. But it's quite interesting to see their motivations for doing open source. So for him, I think to summarize it, it's a key to attract new talent. There's actually also something that Mark Zuckerberg is saying on why they are open sourcing their Llama series, because it's just a way to attract more people, basically the best people available, because the impact of your open source work is just much bigger than if you keep everything behind closed doors. And also another reason why they are doing open source is because they want to lead by example. So rather than following, rather than just mainly copying what has been out there, they actually want to innovate and lead by example, and basically just show off what they are capable of, and then have others building on top of their innovations, which is something that they deeply admire. So I would say, yeah, this is just a brief discussion regarding how we got to the DeepSeek R1 model, what we might expect in the future, and why open source might be beneficial for all. So yeah, I want to thank you for your attention, and I hope you learned something. I will definitely add my slides in the description of the video. Have a great day. Bye-bye.